Okay, before we get started on the CNC, are there any questions that anyone has in any particular area of the CNC that you'd like to address? I don't mean a complete setup. I'm just talking about relatively quick questions.
Well, Thomas had a question when we went on break. So go ahead, Thomas.
It's not about CNC, Frank. Back on the material, can you use that in like doing an armoire where a customer wants the panel, the raised panel part to be walnut, but the stiles and rails to be maple?
And you on a door?
Yes, sir.
Oh, yeah. Yeah.
Okay.
Let me show you how to do that.
Same process.
Say again?
It'd just be the same process then. Just apply it to the stiles and rails and to the raised panels.
Oh, absolutely. Here's how we do that. If we go to the cabinet editor again, and let's put some doors on there. Now, on the material, let's talk about two different things. First of all, if we go to edit the material, let me import the standard material now. And I come down here to where it says door, stiles and rails. You make that birch, for example, and then make this one maple. Does that make sense, Thomas? Sir Thomas Aquinas? Okay. All right, that's one way. Now, what if you change that and nothing happens? This is a tech support question we get all the time. I got to figure out a way of making this more obvious. But if you change this to whatever, let's say I want to edit the Cutlass material and I want that to be birch, how about alder, 3/4 inch alder lumber. All right, I expect my door stiles and rails to be alder, but my panel to be maple. Yet my Cutlass doesn't show that. Why not? Here's the most common reason why. If you go to your door, that particular door style, go to the door library and choose Cathedral, what you'll probably find is a panel and or frame material override. If these are blank, like they are, then those two fields that we just changed will come into play. If these have a material override on them, it doesn't matter what you have in your setup, this is what's going to take precedence. And the reason we do that is because sometimes you have doors that you want to have a particular material, period, no matter what, especially if it's glass. That's the most common use of this. But otherwise, yeah, you can change your panel and styles independently of each other, Thomas. Any other questions before we get started? Okay, now I titled this Smart Rules. However, it's going to be, what I wanted to discuss is an intermediate between Smart Rules and conventional rules. Now, let me explain once again what Smart Rules even are. What Smart Rules are is a method by which CNC machining can be added per job. Notice you have 25 rules, 25 definitions here for machining. You've got, this is for a toe kick, and here's a profile cut, there's a dado cut, and another dado cut, a little notch, and frame, drilling. We have all kinds of machining operations. what those smart rules do, they add literally hundreds of these definitions while it's processing a job, and it does it all automatically so that you don't have to. So the smart CNC rules are a method by which hundreds, and on a big job, literally thousands of these machine operations are created just for that job, and then they're deleted until the next job. So what do I mean by intermediate smart CNC rules? I mean that there's something in between this manual setup and the automatic setup of these smart CNC rules. There's something in between. And what is that? To best illustrate that, I'm going to make two different kinds of parts. Two different kinds of machining. One for drawers and a second one for doors. The actual door itself. Like if you're going to make boring. Jamie, are you online here?
No,
I'm sorry?
he's not.
Okay. Jamie asked this question earlier today, and I told him it was going to be covered here. But let's do drawers. I'm going to go to the CNC Machine Library. And in fact, to make this really easy, I'm just going to delete everything. I'm going to delete all the machine library, all the machine operations for the entire setup. We now have no smart rules and no machining. So I'm going to create one. And when you have nothing and you create one, it gives you the profile cut. So I'm going to make a new definition. And on this new definition, I want this to be a rectangle cut, or a U-cut rather. And on what part? Whenever I make a drawer end and I make the back end. Now the actual dimensions of what I'm about to do, I'm not sure about, but you'll get the idea. I'm going to make a U-shaped machining operation, like 3 dado cuts, you might say, left, top, and right. And I'm going to make the first one down here and the second one over here with a depth of cut, let's say 1 inch, because I want it to go all the way, let's say 2 inches, because I want it to go all the way through the part, and the width is going to be whatever the diameter of that tool is. And I'm going to change this to maybe a 1/4 inch down shear. Notice this is a little notch, and usually it's placed on both sides, and it's for the back end of a drawer side that might be, let's say, 5 inches tall by 16 inches long. Not drawer side, drawer end, excuse me. Now, and before I go on, this particular notch, I want to cut out on the back end of drawer ends, not for all drawer guides, but just for, let's say, I don't have a tandem undermount guide here, do I? Yeah, well, here's the undermount. Just for that particular drawer guide, I want this machine to occur. You see how this is kind of in between a smart rule and just a general machining operation, because we are telling it that we want this machine operation on a particular part under certain circumstances. Those circumstances being that if we're using Undermount guides. So if we're using a different drawer guide, that machining won't occur. Now, once you have that, I can hit the apply button. And if I want to put the same notch on the other side, that notch is pretty big, but it's just to give you an idea as to what you can do, okay? Now, if I want to put this notch on the other side, how do we do that? Let's say I want 2 notches there for my back ends on drawer ends when I'm making undermount guides, when I'm using undermount guides. Well, we make a new definition, and now we have 2 of them sitting on top of each other. If you don't move one of them, you're going to have the exact same machine operation occur twice, and you're going to wonder why the program is machining the same thing 2 times. If that ever happens, it's probably because you have 2 different definitions that are identical, because these 2 are identical right now, until I change it. Instead of bottom left corner, I'm going to go to bottom right corner. On this one, instead of bottom left corner, bottom right corner also, hit apply, and now we have 2 machine operations. And both of them are going to be occurring when we have an undermount drawer guide. Now, why is this one red and this one blue? The reason is that the red one is being displayed on the left-hand side here. If I click on the other machine operation, now that machine operation is being displayed on the left-hand side. So basically, with all drawer parts and with all machining of any drawer part, you have the option of restricting that machining to a particular drawer guide. Or I should say, when a particular drawer guide is being used. Questions on this? Okay, now, what Jamie brought up this morning, he wanted a smart rule having to do with doors, because he's got option 5P, I think it is, where he's got Door Pro as well as Cabinet Pro, and he machines doors. So the question he had was, how does he make the door hinge plate holes, the door hinge holes on the door itself, where you bore out one hole and maybe drill a couple holes on either side of it? Well, we're not going to make a smart rule having to do with that, but what I am going to do is duplicate what you're looking at right now for door parts, so that right now, if you choose any drawer part, any drawer box part, you can assign it to a particular drawer guide. Well, what we also want to do, and what I'll be doing probably by next week sometime, is for every door style, even though the main door style would be door panels, the door part would be door panels, because normally you're not going to machine these, although you could. But for every door part, and we have 3 of them, panels, stiles, and rails, if you select one, on the right-hand side here is going to be the same kind of a drop-down box that you saw for drawers, but it's going to be the door style library instead. Because right now, if I tell the program, here, let's make a new definition. I'm going to make a new definition, and I'm going to tell the program that on door panels, on either one, left or right hinge, either one of them. We want to make a circle. We want to bore out. No. We want to make a hole. Now, what's the difference between a circle cut and a hole cut? The hole cut's right here. And if I choose to put that hole cut someplace, I can give it a depth, a specific depth of, say, 1/4 of an inch. That may not be deep enough, but let's just have 1/4 of an inch hole. Now remember, on all these depths, if you put a positive depth in, like 0.25, then the program is going to cut down to that particular depth. If you put a depth of negative 0.25 or a negative depth at all and hit apply, watch what happens. Now the program will cut down so that it leaves 1/4 of an inch. The benefit, that's used a lot. Negative depths are used a lot in blind dado construction because we want to make sure that regardless of the thickness of the wood that we're using, we want to make sure that we end up with a tenon of a given dimension. Maybe we always want that to be 3/8 of an inch or even 1/4 of an inch. We would put a negative number in there so that if we have wood if we have a panel that's not 3/4 of an inch, but maybe it's 0.722 inches. Well, try figuring out the depth that you should drill that or cut that down to in order to maintain a final thickness of 1/4 of an inch. Well, the program does that automatically. So it doesn't matter how thick your wood is. If you put negative 0.25 in here, it'll figure out how much it's going to drill in order, or cut in a dado cut or a hole, in order to leave 1/4 of an inch or 3/8 of an inch. Anyway, the difference between a hole cut and a circle cut is that a hole cut bores it out. That's why we have these concentric circles. So it actually bores out the hole down to the depth that we need it to be. A circle cut, if I change this to a circle cut, that's not good because that is just a single cut around to a particular depth, and that's it. Now, a circle cut is useful if we're going to cut a hole all the way through the material. Then, right here, we put, let's say, 2 inches and hit the apply button. Now, it's going to go all the way through. Now, notice I said 2 inches rather than whatever the thickness of this material is. The reason is because Kevin Pro has it whenever it cuts anything, whether it be a dado cut, an arc cut, a circle cut, a hole cut, a drill cut, a drilling operation, anything, it always checks the depth of cut to see that if it's legal. By being legal, I mean that 2 inches by itself is far more than the 3/4 inch thick material that we're cutting right now. And so what the program does is if the depth of cut that you're putting here, in this case 2 inches, is greater than the thickness of the material plus the user-defined maximum depth into the spoil board, which I have as 0.007, if it's greater than that number, then Kevin Pro or Door Pro automatically assign it that additive number. And that is the thickness of your wood, whatever it happens to be, plus this number, 0.007, and that becomes the new depth of cut. So you could put 10 inches in there and you're still not going to hurt your machine. I hope. No, just kidding. No, it's a major fail-safe feature. Anyway, getting back to door hinges. Let's say, for example, we have door panels here, and that door panel, I don't know what the diameter would be of a standard door, but I'm going to say that it's 0.25 deep, and the radius of the hole is going to be, let's say, I don't know, 1 inch. Or how about 0.5 inches, so we can see it. So here's the hole. We can place it wherever we want. What I'm doing right now, if you click this little button here, it'll place it approximately as to where you want it. But then you can be more exact. If you want this in millimeter mode, you can change this to millimeters, for example, and tell it you want the center to be, let's say, 37 millimeters from the edge. And whatever distance you want here, you can place them at the same time. So I've got it 50 millimeters away from that edge, from the bottom left, from the bottom corner, bottom edge. But if I want that to be whatever, 60 inches, 60 millimeters, you can do that. What if I want that in the middle? Then I could put 50%, 50%. And now that'll put it in the middle of that from left to right. What if I want that hole in the middle of the part itself? Then I could put 50% here as well in the up and down or in the X direction. Now it's in the very center of the part. But let's get back to not using percentages and putting this as 37 millimeters and this to whatever you want. You can put the bored out hole here and then copy it over to the other side. So a new definition, for example, would be to move that from the bottom left corner to the bottom right corner. Now we have 2 of them. You can also make, and now that's assigned to your door panels. And here you can tell it that this is only going to be good if you have Door Pro. Is only going to be good for a particular door or for all door styles. If you don't have Door Pro or if you don't have the MDF module, then this menu doesn't come on. But if I said all door styles, now these holes are going to be drilled on every single door that we make, no matter what it is. So usually that's going to be for a particular door style. Now, what about the 2 little holes that go on the other side? You can make a new definition. Wait a minute. Yeah, you can make a new definition, and this time we want a different tool, maybe a 5 millimeter drilling tool. And we're going to make a drilling operation. So we're going to make a drilling pattern. We can tell we want 2 holes to be, say, 64 millimeters apart from each other. I think that's correct. I might be wrong on that. But distance between holes, we're in millimeter mode. Let's say it's 64 millimeters. And the first one is going to be placed here. Whoops, here. The second one is going to be placed right after it, 64 millimeters away. Now, if we looked at all of those, notice this says all door styles, panels. What else do we have? There's a circle cut. And this is going to be for all door styles as well. Now, you might want to position that a little bit better than I did. You can change the spacing here to make that, you could use your point of reference here if you want to move the circle, or you can put these machine operations anywhere you want. So this particular hole is telling us we defined it as starting from 34 millimeters from the edge, which I think that's definitely wrong, but you look at your specifications as to what that should be, and a certain distance away from the top edge. So you can make this for your doors, and now every time you make your door styles, that is what is going to be machined. Now, that's obviously not exactly correct, but I think you get the idea as far as how to make those bored out holes as well as the drilling operation. Now, the drilling operation, we do not want to go all the way through. So we can put this in millimeter and inch mode, and you'll see that we're at 1/4 of an inch. Or if you want those just to be a little, sometimes you want these screwed in holes to be just a little mark. So instead of 1/4 of an inch, you could tell that you want the depth of cut to be 0.02 inches. That'll just touch the material itself. It depends on how you want that done. Now, on your Smart Rules, let's go ahead and put our Smart Rules back together. I'm going to go to the library, cabinet library, and activate a library according to our defaults. So this is going to get rid of everything that we've done so far and overwrite all of our setups to put the default setups in when the program is first loaded onto a particular computer. So now, if we go to our setup, we have pull hinge and guide locations, and we have door hinges. Now, right here is an area that's going to do exactly what I showed you a minute ago, all automatically. So instead of having to do what I just showed you and spend 10 minutes, 15 minutes maybe on making those holes and going to your data, your information, your packets to figure out where the boring should be, where the bored hole should be, what the diameter of it should be, and where the hole should be drilled on every single door. Well, actually, all that information is right here, because right in this area right here, we have distance from the top edge of the door to the hinge center line. We have this number as that distance, so we know where to put the middle of that door seat. Over here, if we have short doors, we know where to put that door seat. If we have tall doors, we know where to put that door seat. Same thing for the bottom. The bottom and the top are usually the same, but not always. Now, because we have that information, because we have this information, number of mounting holes, usually that's 2. the center line of holes from front edge of the side panel. Remember I said, I think it was 37 millimeters. Well, you put that whatever you want here in inches or millimeters. And so all you'll have to do is figure this part out by the specifications on a particular hinge, and then a smart rule will apply this immediately, just like it does the hinge plate holes for your unfinished ends and finished ends. So right now, if you go back to our CNC Machine Library, right now it's a bit of a pain to put the door hinges in. Well, I just overwrote this, so they're not showing here. But the bored out hole and the two hinge plate holes, where those are placed, takes a few minutes, and then it'll change if you, perhaps it might change if you change your door hinge. But this is what we have right now that solves that problem. But what we'll have as a bona fide smart rule that will take the information from your hinge plate area, this will be far quicker and far more efficient than what I showed you a second ago. But what I showed you a second ago won't work because you can make those holes dependent upon a particular door style. Questions on this? This, of course, is only useful if you have the Door Pro module. Now, what numbers are going to be used? If we generate a Cutlass report, whether you have the CNC module or not, or the CNC version or not, if we have a couple of cabinets here, and here I'm going to make a bunch of cabinets here just so we have a whole bunch of cabinets in the program or in this job. These cabinets right here are going to be placed automatically. So I'm going to go into the floor plan generator. And the only reason why I'm doing this is because I want to get a bunch of cabinets in here quickly. So I'm going to make a wall and I'm going to autofill that wall with cabinets on top of what we've already done. If I hit the OK button at this point, we'll get a bunch of cabinets. And now those cabinets, after setup, should be ready for perfect cut listing, pricing, and CNC operations. Better be, otherwise we have a problem. Okay, so if we refresh the screen and exit, we now have a bunch of cabinets in here. So if I go to reports and generated a Cutlass report on this, on every single Cutlass report, oops, wrong button. Let's try that again. Okay, let's figure out a Cutlass for the entire job. And now we have a drawer box report. If we look at the drawer box report, we can see our drawer box sizes and all the various dimensions of each of the part. However, if we generate any Cutlass report, now that's a Cutlass report, I realize. When I say any Cutlass report, I'm talking about any general Cutlass report. We have door reports, drawer box reports, and general Cutlass reports. Any general Cutlass report that we make, such as, well, just about anyone, and also door reports. We also get the information that is going to be on that Hinge report. This information right here is all taken from your door hinge setup screen. Excuse me. Sorry about that. So you have the information right now as far as where your door machining should occur. But the actual machine itself will be much better made when that information becomes a smart rule, a bona fide smart rule. Right now, it's in between the two. Now, let's go to the smart rules again, because what we've done here is we made it so that you can have a depth override this per smart rule, because what we found was that the same universal that's made, and I'm assuming you know what a universal is. If you don't, interrupt me now, okay? Because I do want to explain that. But I'm assuming you know what a universal is. And that universal CNC operation is supposed to be able to be used by several smart rules. But what we found was that we were restricted, and sometimes we had to make the same universal basically 2 or 3 or 4 times just because of one thing was wrong or different, and that was the depth. So we have a depth override here that if it's 0, it's ignored, and the depth that is used in the CNC definition itself is utilized. So if we have, let me exit out of here for a moment and go to the CNC Machine Library. What that means basically is here, this is a universal. It's for the right toe. I don't know if you can see it because I can't. Hold on. We need to find the profile cut. There it is. Okay. Now, any of these tools, any of these definitions that we have here, all these definitions here, each of these definitions that are universal has a particular depth associated with it. Here's a cutting depth on this last column. That cutting depth will show and will be transferred over to the universal itself. Excuse me, the smart rule itself when this is selected. Notice it says full dado for vertical divider. So if we go to the CNC Smart Rules and we select the full dado for horizontal divider, that depth is going to be used in this rule unless I have something other than 0 here. Now, in this particular case, you can also enter negative depths here. And the negative depth here will have the exact same effect as what we talked about earlier. So if we put a negative 0.25 in there right now, for example, whatever the thickness of the panel is, it'll leave a 1/4 inch. Now, something that a lot of people may not be using is this button right here. What I like to do now is when I'm making the smart CNC rules and you could do this for a new setup. If you've already got smart CNC rules, that's fine, but you might be making another setup. Well, this makes life a lot easier if you concentrate on just your left ends, unfinished ends, for example. And then once you've done all your left finished ends, you click this button. And what that'll do is, number one, it'll delete all of your right unfinished ends, all your right unfinished end rules. and then it'll go through each of your left unfinished ends and copy them and adjust things if necessary to your right side. It's a real easy way of making sure that you don't have anything left out, because what I found in the past is when we're making CNC rules for left and right ends, we might make one for the left side, but we'll forget to make it for the right side, or we'll make it wrong for the right side. So that has a tendency of easing mistakes that we might make. Any questions? Any questions on any of these SMART rules for that matter, or on any particular aspect of SMART rules that you might want clarification on?
Yeah, Frank, Zia here.
Go ahead.
Well, remember we told you about when we build a base cabinet, we normally would dado the unfinished end on the right and left, and then on the underneath too. So then we would slide the back piece on top. That way it fits good, and you wouldn't see any of the bolts or anything.
I'm sorry, I didn't understand that question. Would you say it again, please?
When we build a base cabinet, we normally, what we would have to do, we would have to groove the two unfinished ends and then the base. So for us to slide the back piece behind it. And what I wanted to know is, would I have to make 3 different definitions for a dado?
Oh, I see, for a back. Yeah, okay. I think I'll try to answer that. Let me know if I answered okay or if I don't. First, you go into the CNC Machine Library. Here, I'm going to delete all these so we start fresh, and so I don't keep getting that error message. We're just going to have one SMART rule having to do with your backs, okay?
Okay.
So what you could do, this is one way of handling that. You can say that we want to make a new definition, and that new definition is going to be a straight cut. We call it a straight cut rather than a dado cut, because that can also be a rabbet. So for all cabinet prototypes, we're going to machine a finished end, a right finished end or a left finished end. Now we're going to use now whatever you're using might be a little bit different, but this is just an example, okay?
Okay.
We're going to use a 1/4 inch down shear, and that's the tool that we're using. And this is going to be our back dado, or dado for back. And instead of all cabinet prototype, for all cabinet prototypes, you can create one here, and everything, all your cabinets will have it, period. Well, what if you have a cabinet without a back on it? Then you have a machine operation that looks kind of sloppy because it's in there anyway. So if I told the program that I want the width of the cut to be equal to a percentage of the part thickness that's going to go in there, I could choose cabinet backs. You know what? My material's messed up. Let me go fix my material real quick. I'm going to go to Global Changes, All Cabinets, Maple, okay, and okay, all of my material is fixed now. So let me go back to the CNC setup. You know, when I go back and forth between setups and different kinds of methods of programming, this this software, it's pretty easy to get things mixed up. So what I just did was I got the materials mixed up, and so I just cleaned it up real fast. Going back into the CNC Machine Library, now you'll notice that the material is a 1/4 inch pre-finished maple, because I have the width of cut equaling the width of that part. If I take a micrometer to that, it might be 0.22 inches, not 0.25 inches, but it'll adjust the dado according to whatever that material is, the actual thickness in inventory. And remember, you change the thickness of a particular material in one place, inventory. Now, the depth of the cut for this might be a 1/4 inch or whatever. Now, I'm going to make this go from one end to the other end. If you prefer, you can make, it doesn't have to be the entire distance. But I've got this to be in the entire distance. The distance from the top might be equal to my nailer, if I have the nailers in the back. So now we can change this to, let's say, 5/8 or 0.75, 0.75. Now, if I, and we're done. Now, this is one way of making a dado in an unfinished end, in a right unfinished end for all cabinets, because whether they have a back in it or not. The problem with this, see, I've got it for all cabinet prototypes, unfinished ends. This is the machine I want. The problem with this is that what if you make a cabinet without a back in it? That becomes a serious problem, because now you've got sloppy machining, because in the unfinished end, you got machining where there shouldn't be any machining. That's why we prefer to use this as a smart rule. So instead of all cabinet prototypes, we're going to tell it that this is a universal instead. Now, as a universal, now we can create a smart rule from this. Zia, you with me so far?
Yeah.
Okay. So we go to CNC Smart Rules. Yeah. We go to CNC Smart Rules and we tell it that dado for a back, which is right here. Notice it says front edge of the part. That's okay for right now. I'll tell you why in a minute. And I want to test this one rule on a wall cabinet. Now, all you gotta do is hit proceed to the test. And we get nothing. Why is that? Do we not have a back on that cabinet? Let's go to that cabinet and make sure we have a back on it. Okay, we do have a back on it. Oh, I see, okay. Notice we got no machining. And the reason for that is because if we go back to CNC Smart Rules and click Smart Rule Options, usually we want to check right here. Always apply smart rules that result in machining dado cuts even when a zero inset exists. So now we're going to select the dado in our unfinished ends whenever a back intersects a right unfinished end. And we want it to appear exactly as is shown in the universal definition. Now, when we choose that same cabinet and proceed to the test, we still don't get anything. Hold on. Data for back, unfinished ends. Oh, look at this. You see it right here?
Yeah.
I had that for left unfinished ends. Now let's try it for the right, because I think I had for the right unfinished end over on my other side. I believe I did. We'll find out. Yeah, there it is. So this is for a right unfinished end, and we now have a dado. But what if we take the back out? For that second cabinet, so for cabinet number 1, we have a back. For cabinet number 11, I'm going to take the back out. Now, for whatever reason, I've chosen not to have a back for this cabinet. Maybe I have this as a base unit and I have it as a double access cabinet. That's one example as to why you want to do that. But for whatever reason, we don't have a back on that cabinet. That's cabinet number 11. Now, let's go back to the CNC setup. And let's, whoops. On the Smart CNC rules, we'll look at it again. Let's look at cabinet number 2. That's the one that we have a back on. And you'll notice that this is in the rear. Now, if you saw that this is in the front and it was wrong, all we have to do is reverse it along the x-axis. This happens to be correct, but you see, you can also have that wrong, in which case you would have to reverse it along the x-axis. If you did that, wherever this happens to be, it'll go in the opposite direction. So now, instead of being in the rear, it's in the front. Now, we don't want the back to be in the front, obviously, because it was right in the first place. But I do want to show you that you can revert. If you have a machine operation that is placed in the wrong area, you can reverse that by using any of these 2 reversal checkboxes in the x-axis or the y-axis. Now, let's look at a cabinet number 11. Remember, I took the back off of that cabinet. So if I do the exact same thing on that particular cabinet, we will not get any machining because there's no back to put into that groove, into that dado. Does that answer your question, Zia?
Yeah. What I also wanted to ask you too, so we did this, we made this definition for one of the unfinished end on the right side. So would we have to make another definition for the left side and another definition for the base piece? And let's say we make we're making a wall unit. So that way we'd slide from we would dado the left arm.
Zia, I'm sorry. I'm sorry to interrupt you, Zia, but let's handle that individually because we've run out of time.
Okay.
Okay. But I'll be more than happy to answer that question individually. Okay.
Yeah, no problem.
Okay, Valerie, you want to take over?
We did have one more question from Frank. He said, I'm currently not on a device with no mic, but is it currently not possible to place adjustable shelf holes on cabinet backs?
Yeah, you can do that. We have a drilling pattern for your adjustable shelf holes. You'll use the exact same ones that you were using before. And no. You have to set this up for your, not your dado, but for a drilling pattern, general drilling. Actually, you know something? If you go to the Smart CNC rules, after you've done that, go to these Smart CNC rule options. Right here, you say add a third adjustable shelf holes over the depth of a certain amount. That's on your unfinished end. And right here, minimum width of a cabinet's back where one set of adjustable shelf holes should be drilled. You put a number in here other than 0, and you will get holes drilled in your back. Now, if you have a really long cabinet, you might want 2 sets of holes. You put that number that defines a long cabinet, and you'll get 2 sets of holes drilled equidistantly from each other. And same thing for 3 sets of holes and 4 sets of holes. Okay? So you probably have, if you look at this, these Smart Rule options, these are probably blank or equal to 0. Make them equal to something and you'll get your holes in your back. Okay? Okay, Valerie?
Okay. Thanks everyone for coming. If you have other questions that come up after, you can always email or call. I'll be starting a discussion on the private Facebook group. If you're not a part of that group, then go ahead and join that group about restructuring the webinars. If you weren't here at the beginning, we talked about restructuring the webinars to reach as many people as possible and to be as effective as possible at the same time. So we had a couple ideas, and I'll put that on the Facebook group so we can start a conversation to best meet everyone's needs. Okay, and we'll see you next time.